Installing a 5% line reactor on the input to the variable frequency drive or VFD can indeed help protect it from voltage spikes and other power quality issues. Line reactors function as filters, effectively reducing the rate of change of voltage, which is dV per dt, and the rate of change of current, or dAs per dt. These reductions mitigate electrical stress on the electronic components within the VFD. It is generally considered a sound practice to install both a line reactor and a transient voltage surge suppressor, also known as TVSS, for variable frequency drive applications. This is particularly important in environments that experience frequent power outages and phase failures. There are several reasons for installing both a line reactor and a transient voltage surge suppressor. Firstly, voltage spikes. Power outages in various electrical events can generate voltage spikes that surpass the VFD rated voltage. A TVSS is designed to divert these excessive voltage spikes to ground, safeguarding the VFD from potential damage. Secondly, dV per dt and dAs per dt reduction. A line reactor diminishes the rate of change of voltage and current. By doing so, it alleviates electrical stress on the VFD components, thereby enhancing its reliability and lifespan. Thirdly, phase failures. Phase failures can lead to overvoltage conditions within the variable frequency drive. A line reactor plays a crucial role in limiting these overvoltages, thus protecting the VFD in the event of a phase loss. Fourthly, improved power quality. A line reactor and TVSS collectively enhance the overall power quality by filtering out harmonics and other electrical disturbances. These disturbances can adversely affect the performance of the VFD and other electrical equipment connected to the system. Harmonics, in particular, are unwanted frequencies that can distort the sinusoidal waveform of the electrical supply. These distortions can cause overheating, equipment malfunction, and reduced energy efficiency. A line reactor helps to dampen these harmonics, providing a cleaner power supply to the VFD. Transient voltage surge suppressors are designed to protect electrical devices from voltage spikes known as transients. These surges can be caused by lightning strikes, switching operations, or other electrical disturbances. The TVSS works by diverting the excess voltage away from the sensitive components of the VFD, grounding the surge. Different types of TVSS devices exist, each designed for specific applications and voltage levels. Selecting the appropriate TVSS is crucial for ensuring effective protection. Furthermore, the impedance of the power source influences the effectiveness of the TVSS. A lower impedance source allows the TVSS to respond more quickly and effectively to voltage surges. The 5% impedance value for the line reactor is a common choice for VFD applications. The percentage refers to the voltage drop across the reactor at the VFD full load current. A 5% reactor provides a good balance between protection and performance. Reactors with higher impedance values provide greater protection, but can also lead to increased voltage drops. Reactors with lower impedance values offer less protection but have a smaller impact on voltage levels. When selecting a line reactor, it is also important to consider the VFD current rating. The reactor should be sized to handle the full load current of the VFD. Choosing an undersized reactor can lead to overheating and premature failure. Additionally, the reactor's inductance and resistance values play a role in its performance. Higher inductance values provide greater harmonic filtering, while lower resistance values minimize voltage drops. The reactor's design should also account for the ambient temperature and operating environment. Factors such as humidity and dust can affect the reactor's performance and lifespan. Proper ventilation is essential to prevent overheating. The installation of a line reactor and TVSS requires careful consideration of wiring practices and grounding techniques. Proper grounding is crucial for ensuring that surge currents are safely diverted to ground. The wiring should be sized appropriately to handle the VFD current and voltage requirements. It is also important to follow the manufacturer's instructions for installation and maintenance. Regular inspections should be conducted to check for any signs of damage or wear. The TVSS device should be tested periodically to ensure that it is functioning correctly. Some TVSS devices have indicator lights that show their status. If the indicator light shows that the device has failed, it should be replaced immediately. In addition to line reactors and TVSS devices, other power quality solutions can be used to protect VFD. These include harmonic filters, power factor correction capacitors, and uninterruptible power supplies, also known as UPS. Harmonic filters are designed to reduce the levels of harmonic currents in the power system. Power factor correction capacitors improve the power factor, which reduces energy losses and improves the efficiency of the electrical system. Uninterruptible power supplies provide backup power in the event of a power outage, ensuring that the VFD continues to operate without interruption. The selection of power quality solutions should be based on a thorough assessment of the electrical system and the VFD-specific requirements. A power quality audit can help to identify potential problems and determine the most appropriate solutions. Furthermore, surge protection should be considered for the motor leads as well, especially with longer motor cable lengths. This is because voltage reflections can occur on the motor leads, which can damage the motor insulation. Motor lead reactors or dV/dt filters can be used to mitigate these voltage reflections. These devices reduce the rate of change of voltage on the motor leads, protecting the motor insulation. The motor cable should also be shielded to reduce electromagnetic interference, which is also known as EMI. EMI can interfere with the operation of the VFD and other electrical equipment. The shield should be properly grounded to provide effective EMI protection. Furthermore, the grounding of the VFD and motor is critical for ensuring proper operation and safety. The grounding system should be designed to minimize ground loop currents. Ground loop currents can cause voltage drops and interfere with the operation of sensitive electronic equipment. It is also important to follow the National Electrical Code or NEC guidelines for grounding. The NEC provides specific requirements for grounding electrical systems. In addition to surge protection and harmonic filtering, it is also important to consider the voltage and current ratings of the VFD. The VFD should be selected to match the voltage and current requirements of the motor. Operating the VFD outside of its rated voltage and current limits can lead to premature failure. Furthermore, the VFD should be protected from environmental factors such as temperature, humidity, and dust. Enclosures can be used to protect the VFD from these environmental factors. The enclosure should be rated for the specific environmental conditions. For example, an M4 enclosure is suitable for use in wet locations, while an M12 enclosure is suitable for use in dusty locations. Regular maintenance is essential for ensuring the reliable operation of the VFD. Maintenance tasks include cleaning the VFD, inspecting the wiring, and checking the cooling system. The VFD cooling system should be kept clean to prevent overheating. Overheating can damage the VFD components and lead to premature failure. In conclusion, given the potential risks to the VFD in this application, it is highly recommended to install both a 5% line reactor and a TVSS. These devices will provide additional protection against power quality issues and help prevent premature variable frequency drive failures. Remember that while VFD offer numerous benefits, including energy savings and precise motor control, they are susceptible to power quality issues. By implementing proper protection measures such as line reactors and TVSS devices, you can ensure the reliable and long-lasting operation of your variable frequency drives. Line reactors and TVSS devices are cost-effective investments that can prevent costly downtime and equipment replacement. They are especially important in industrial environments where power quality is often compromised. Consider consulting with a qualified electrical engineer to assess your specific needs and recommend the most appropriate protection measures for your variable frequency drives. By taking proactive steps to protect your VFD, you can ensure that they continue to operate reliably and efficiently for years to come. Line reactors and TVSS devices are just one part of a comprehensive power quality management strategy. Other measures such as harmonic filtering, power factor correction, and surge protection can also be implemented to improve the overall power quality of your electrical system. Remember that power quality is not just a concern for industrial environments. It is also important in commercial and residential settings. Poor power quality can damage sensitive electronic equipment and reduce the efficiency of electrical appliances. By taking steps to improve power quality, you can protect your equipment and save money on energy costs. In addition to the technical aspects of line reactors and TVSS devices, it is also important to consider the regulatory requirements. The National Electrical Code, also known as NEC, provides specific requirements for the installation of these devices. It is important to follow these requirements to ensure that the installation is safe and compliant. Furthermore, local codes and regulations may also apply. It is important to check with your local authorities to determine the specific requirements in your area. The installation of line reactors and TVSS devices should be performed by a qualified electrician. A qualified electrician has the knowledge and experience to install these devices safely and correctly. Improper installation can lead to equipment damage and safety hazards. Furthermore, it is important to keep accurate records of all maintenance and repairs performed on the variable frequency drive. These records can be used to track the performance of the VFD and identify potential problems. Regular maintenance and record keeping can help to extend the life of the variable frequency drive and prevent costly downtime. In addition to the benefits mentioned above, line reactors and TVSS devices can also improve the stability and reliability of the electrical system. By reducing voltage sags and swells, these devices can help to prevent equipment malfunctions and improve the overall performance of the system. Furthermore, line reactors can help to reduce the amount of electromagnetic interference that is generated by the variable frequency drive. EMI can interfere with the operation of other electronic equipment and can also cause communication problems. By reducing EMI, line reactors can help to improve the overall reliability of the electrical system. The selection of line reactors and TVSS devices should be based on a thorough understanding of the electrical system and the variable frequency drive specific requirements. It is important to consider factors such as the voltage, current, frequency, and harmonic content of the electrical system. It is also important to consider the environmental conditions and the potential for voltage surges. By carefully considering these factors, you can select the most appropriate line reactors and TVSS devices for your application. In addition to the technical aspects of line reactors and TVSS devices, it is also important to consider the cost. The cost of these devices can vary depending on the size, type, and features. It is important to compare the costs of different devices and choose the one that provides the best value for your money. Furthermore, it is important to consider the long-term costs of ownership. These costs include maintenance, repairs, and replacement. By considering these costs, you can make a more informed decision about which devices to purchase. The installation of line reactors and TVSS devices is a relatively simple process. However, it is important to follow the manufacturer's instructions carefully. A proper installation can lead to equipment damage and safety hazards. Furthermore, it is important to use the correct tools and equipment. Using the wrong tools can damage the devices and can also be dangerous. The maintenance of line reactors and TVSS devices is also relatively simple. However, it is important to perform regular inspections to check for any signs of damage or wear. If any damage is found, the devices should be repaired or replaced immediately. Furthermore, it is important to keep the devices clean and free from dust and debris. Dust and debris can reduce the performance of the devices and can also cause them to overheat. In addition to the information provided above, there are many other resources available to help you learn more about line reactors and TVSS devices. These resources include technical manuals, application notes, and online forums. By taking the time to learn more about these devices, you can make a more informed decision about whether or not to install them in your electrical system. Line reactors and TVSS devices are just two of the many power quality solutions that are available today. By implementing a comprehensive power quality management strategy, you can protect your equipment, save money on energy costs, and improve the reliability of your electrical system. Remember, power quality is an important aspect of electrical system design and operation. By taking the time to understand the basics of power quality and implement appropriate solutions, you can ensure that your electrical system operates safely, efficiently, and reliably. In conclusion, the integration of a 5% line reactor and a transient voltage surge suppressor is highly recommended. These elements will enhance protection against prevalent power quality concerns and contribute to the prevention of premature variable frequency drive failures. The information discussed here emphasizes the importance of proactive measures in safeguarding electrical systems against power quality issues. By understanding the function and benefits of devices like line reactors and TVSS, individuals can make informed decisions to protect their equipment and ensure reliable operation. Power quality is a multifaceted subject, and staying informed about the latest technologies and best practices is essential for maintaining efficient and safe electrical systems. In summary, this comprehensive exploration underscores the importance of power quality and provides valuable insights into effective protection strategies for electrical equipment. By adopting these measures, individuals can enhance the reliability, longevity, and overall performance of their electrical systems.